Hello, this is Mr. Nakauchi, and we're going to be talking about the law of signs. Hopefully you already saw my other video about classifying and labeling triangles. I'm going to draw a random triangle, and I'm going to label the corners, the angles, any capital letters. I'll call it A, B, C. You can use any three capital letters you want. And I'm going to label the sides across on them. This is side A, because they're opposite, side B, and side C. All right, so we have three sides, three angles, and the law of signs says pretty much that if you know any three of these components out of the six, you can solve for the other three. You usually use the law of signs to do it. The law of signs doesn't work every time. If it doesn't, there's something called the law of cosines to help when this doesn't work, but this works most of the time. Right? Now, before we get to how the law of signs works, you have to know something that I have called the partners of the triangle. And the partners pair off the angle with its corresponding side. All right. So meaning like angle A is partnered with side A. Right. And by the same token, angle B is partnered with side B. Partners are always across from each other, and angle C is partnered with side C. So I would call this a partner. It's angle and side. This is a partner. It's angle and side. There are three partners, or pairs. You can call them pairs. I tend to call them partners because they kind of work hand in hand, just like partners work hand in hand. All right, so three partners, and here's how the law of signs works. The law of signs says that take one partner and find the sine of that angle. So the sine of angle A over its partner side would be equal to the sine of angle B over its partner side. And now that's enough. And there's three sides, so angle C, the sine of angle C over its partner side C. That is the law of signs. It says that all three of those things are equal. Now this baffles some students because they're like, wait, how can you have three things that are equal to each other? How am I supposed to solve that? Well, you don't usually put all three of them. What we're saying with this is that you can take any two of these. So sometimes you just use just the A and B partners. And sometimes you just use the B and C partners and set them equal to each other. And sometimes you just use the A and C partners and set them equal to each other. So you just take any two of these three and you set them equal to each other. And so if you get, now we're going to need a calculator, but if you take the calculator sine A and divide it by side A, the decimal you get will be equal if you take the sine of B over the side of B and divide it. And that will be equal if you take a calculator and find the sine of C and divide it by the side of C. All right. Now, you can also flip this over the other way and have the sides on top, because proportions are the same as long as you just flip everything. So side A over angle A over side B over sine of B, which is also equal to side C over the sine of C. So you can actually kind of write that either way. You can put the angles on top and the sides on the bottom, or you can put the sides on top and the angles on the bottom. And you could just take just those two and set them equal, or you could just take just those two or those two. Now what you can't do is mix them up, okay? So you cannot do this. You cannot say side A over sine A equals B over sine of B. That does not work. You can't have side over angle and, I'm sorry, I did that incorrectly. That is true. You couldn't have sine of B over the side of A, or sine of B. Let me write that again. So you could not have A over the sine of A. You could not have that equal to sine of B over the side of B. Those two things are not equal. Okay, those don't work. So you have to make either the side is always on top and the angle is always on the bottom, or always have the angle on top and the side on the bottom. It doesn't matter, but you can't mix it up and have side over angle equals angle over side. You can't do that. So whatever two you pick, you have to take two from the same grouping. This is a grouping. You can pick any two from that, or pick any two from this grouping. You can't mix something from this group or that group. So whatever pairing you start with, you have to stay consistent with the same pairing all the way through. Okay, so these are the basic. Now, a lot of books just use this one. That's kind of the primary one, all right? But a lot of books use this one as well. It kind of goes either way, but this seems to be the one that used more often. I say use the one that helps you out, because you're going to use these to solve for missing elements, all right? Some of these things are going to be missing, and I found that whatever is missing, put it on the top. Put the missing parts on top. All right, so we're going to see what I mean in just a second. I have two examples for you. So let's start with example one right here. We're going to do something called solve the triangle. Now, solve the triangle means I've given you some elements, but not all of them. You have to find the rest on your own. So this is what you see here. And I'm going to note in a highlighter what has been given. I've given you that angle B is 60. I've given you angle A is 25. And I've given you that side A is 12. That's given information. I don't know what angle C is. I don't know side C, and I don't know side B. So these are the three elements I know, and these are the three elements I don't know. So I can use a law of sine to kind of figure this out. Now, actually, there's other laws you can use. Right? There's another rule back from geometry called the sum of angles in a triangle. And if you remember in geometry, there's three angles in a triangle, and those three angles always add up to 180 degrees. So you can use your old geometry rules as well, because if you know that, you actually don't need the law of sines to figure out this angle. Right? That angle, 180, so 25 plus 60 plus angle C is going to equal 180. And to solve for C, we'll just subtract that. So it's going to be 180 minus 25 minus 60. You can kind of do that in any order you want. So if you need to, you can get out a calculator. All right, so 180 minus 25 minus 60, and I get 95. All right, so angle C is 95 degrees. So that's done. I actually didn't even need the law of sines. All right, so that's it. But I don't know these two sides. And I can't do the Pythagorean theorem because Pythagorean only works if the degree is 90. This is 95. So as soon as it has to be a right angle, 95 is not a right angle. Only 90 degrees are right angle. So Pythagorean theorem is out. But I can use the law of sines. Now I have two missing sides, and I try to pick one that might have a partner or half a partner. B has half a partner because its partner is 60, so I have half a partner, and C has half a partner, and A has everything. And if everything is there, let's start with that. All right, so I'll start with that. And then let's pick B. We'll try to find out side B next. All right, now since B is what's missing, I'm going to put the B on top. So I'm going to say B over the sine of 60, because that's what the law of sines says. Take the partner, so I like to put the missing element on the top, and B is missing, and set that equal to the partner that we know everything, which is A. So the side of A is 12, and the sine of A is 25. Right, because that one we know everything. This is what's missing. Now the C we don't know, but we're gonna have to save that for a different equation because we can only use two at a time to solve. And again, remember, I know the formula has all three. All right, the formula has all three, but you can only use two at a time. You really can't quite do all three at once. You can only pick two at a time. So I've picked the B and the A to work with first. The C is gonna have to wait until later. All right, so I picked the A one and the B one. And now I'm just gonna solve this for B. Now it's B divided by the sine of 60. Now if you're dividing everything, anything divided, to do that, get rid of it, you do the opposite, and the opposite of dividing is multiplying. So I'm gonna multiply both sides by the sine of 60. Now these cancel, so B is gonna equal 12 times the sine of 60 divided by the sine of 25. Now the signs do not cancel because it's the sine of 60. If there's a sine of 60 over the sine of 60 and these two numbers are the same, then it would all cancel. If the numbers are different, you can't just cancel the signs. It doesn't work like that, okay? And so now, to do this, you have to just use your calculator, all right? Once you get to this point, you just have to use your calculator and work from there, all right? And just use your calculator. Now, I like to do stages and just do the top half of the fraction first. So I do 12 times the sine of 60. Make sure you're in degree mode, and I get that number. Take that number and divide it by the sine of 25. Right? The answer button just shows up by itself on my calculator. Your calculator may vary. And my answer is 24.59. The decimals goes on forever. I only need you to round your answers to the first decimal point. And since it's 5.9, I'm just going to round it to 0.6. Right? And that's a side, and the units are inches. So that's inches. Right? So B equals 24.6 inches. There's my answer for side B. Now, some calculators allow you to do the whole thing in one step. Double check, because if you do it in one step, it gives you a different answer depending on how the calculator works, because not all calculators actually work the same way. So just experiment on your own calculator and just make sure you get this number. All right, how you do it might vary a little bit. Okay, now that's it for B. I still need to find C. I don't know what C is, but I can take the same partner. I can take the same partner, A, which was 12, because the missing thing is a side. The side is missing, so I'm going to put all the sides on top. So that's a side. So it's 12 over the sine of 25, and I set it equal to the missing side here, C, over the sine, and that angle I know, it's sine of 95. Right? So I take this pair and set it equal to this pair. I could have used the B pair as well. I could have set this equal to the sine of 204.6 over the sine of 60. The reason I decided not to use the B is because remember, this answer was rounded. So if I use a rounded answer in the next problem, the next one's going to be a little bit off, and this answer is not rounded, it's exact. So I chose to use the exact one instead. Okay, and so now I need to solve for C. I'm going to do the same thing. It's C divided by sine of 90.5, so I'll multiply both sides by sine of 95. And those cancel, and it's now sine of 95 times 12. You can change the order. 12 times sine of 95 divided by the sine of 25 equals C, and just work that out with your calculator. Now it's calculator time. So here we go, clear it all out. 12 times the sine of 95, and divide that by the sine of 25, and I get 28 point, and just round to the nearest decimal. 28 is going to be 0.3. This is a side, so it's going to be in inches. So there I go. So 28.3 inches. So that is solving that triangle. That is everything I need to know for that problem. Okay, so now, because once you have all the elements, that's everything you need to know, and it is solved. Okay, so there is your first example. All right, next example is right here. Okay, and we'll put this paper in case we need more. Okay, so we're going to solve that triangle. Now this time, notice they didn't give a picture. So I'm going to highlight what's given. And this is all that's given, so we know what was given and what we figured out on our own. All right. But so if they don't give you a picture, you have to draw it yourself. Now, I don't know what the triangle looks like. It could be obtuse, it could be acute, but just draw a random triangle and just label the sides anywhere A, and there seems to be a B and a C. Right? I don't even know where they're going to go. I'm just putting it somewhere random. But whatever corner I call A, that's going to be my 36 degrees, so that has to go by the A corner. Side A is 8, and they have to be opposite each other. So there's my 8, right? And side B is 5. And since I made that angle B, the 5 has to go over there. So there's my drawing. Now yours might look a little different depending on where you put the A's, B, and C's. But the important thing is the information should be, like the 5 and the 36 should be next to each other. The 8 and the 5 should be next to each other no matter how you drew your triangle. As long as you do it correctly, those facts should still remain. Now what's missing? Side C, angle C, and angle B. Now this one is a little more challenging because this time, last time we had two angles and we were just able to solve the third by geometry. Well, if you just got one angle, I can't use any geometry. So I'm going to need to solve for some angles here. Right? I do have one partner already. If you look for any partners you have, and it looks like I already have A partners. So I'm probably going to base everything off of that because you want to have at least one set of partners that you know already. Now what's missing? Now we have three things missing, a side and two angles. What do you want to find first? Now actually the C stuff is actually a little hard to find because you can't have two unknowns. I don't know angle C and I don't know side C. So you can't have two different unknowns in a problem. So I can't actually do anything with the C's at all. The B's, I know one of its partners, the 5, and I don't know that angle. So since I don't know the angle, I'll try to solve for that first. So since I'm solving for an angle, I'll put that on the top. So I'm solving for angle B over its partner side 5. I'm going to set it equal to sine of 36 over 8 because those are the sides for A. Okay? And this time I'm solving for angle B. Now, I can multiply both sides by 5, just like I did before. I'll put it over here. That cancels. So sine of B, right, equals 5 times that. And so now I get to use my calculator. So time to use a calculator. So that's a 5. 5 times sine of 36 divided by 8. And I get the decimal 0.3673. Okay, it goes on forever, but I'll just round to 4 decimals because now I'm not rounding just 1 because that's actually not my final answer. The sine of B equals that. This is not the angle. Right? Somehow have to get rid of this sine. Now, you're probably thinking, well, I'll just divide both sides by sine, but this is not sine times B, right? The B is part of the angle. So I can't just divide both sides by sine. Like what? If you try to do this and divide by sine, your calculator is going to be the sine of what? It's just going to give an error message. So there's another, I just have to get this B alone. So how do I get rid of sine? What's the opposite of sine? The opposite of sine is not 1 over sine. The opposite of sine is the inverse sine. I'm going to take the inverse sine of both sides. All right, that's my opposite. Right? And sine and inverse sine cancel. So then I just get angle B by itself. And now I have to find the inverse sine of that number. So now I go back to my calculator. Luckily, that number is still in my calculator. So I'm going to hit the inverse sine button. And you could just enter these decimals. You might round it off a little bit. Remember, I have the feature where I can just use the answer button to just use the last answer. See my calculator video of how to do that. That means it's going to take the decimal from there, hit enter, and I get 21.55 degrees. I'm going to round that to 6. So my answer is 21.6 degrees. It's common to get decimal answers. Okay, so that's how you do that. So when you have to solve for an angle, eventually you have to get rid of the sine, and the opposite of sine is the inverse sine. So those cancel, and then you got to take the inverse sine of that decimal, and that's going to get you your final answer. So there is that answer. We figured that out. Okay, now here's some good news. Now that I have two angles, I can use my sum formula, and it's going to be 180 minus 36 minus 21.6, I'm sorry, and that will equal angle C. All right, so 180, get your calculator, minus 36 minus 21.6, I get 122.4 degrees. So there's my angle C. So I didn't even have to use the law of sines. Sometimes you mix, so 122.4 degrees. Sometimes you mix the triangle rules and the law of sines hand in hand. They kind of go together, hand in hand. One will help you get to the other. As soon as you have two angles of a triangle, just use your sum of the angles of a triangle formula to get the third angle. That's much, you don't really need to use the law of sines for that, okay? So that's done. So the only thing that's missing now is side C, right? But I have half of its partner now. You have to have at least half the partner there. If both of them are gone, you're kind of stuck. But I have half the partner there, okay? So half the partner, is, now again, I'm going to base everything off this one because that's very accurate. And the side, and the thing I'm missing is the side. So I'm going to put C on top. So C over the sine of 122.4 degrees equals this side, which was 8 over the sine of 36 degrees. Now you could have used this pair, but remember that was rounded, so it's gonna be a little bit off. This one is exact, right? So once you find one to use, I just like to keep using that same one over and over again. All right, multiply both sides by the sine of 122.4 degrees. All right, that cancels. So C equals whatever that is, and it's just, again, time for the calculator. So we just hit the calculator for everything. So 8 times the sine of 122.4 divided by the sine of 36. And I get 11.5 when I round that off, 11.5. So 11.5, and they did not give units this time. So if they don't give units, then that's fine. Sometimes they don't, right? So 11.5. That side of the triangle is 11.5. So there's your final answer. So we have solved that triangle. Okay, so those are your two examples, but I have one other little bit of information. Right? So please notice so far, now if we classified that, actually let's not look at that yet. This triangle, the information we knew at the beginning was an angle and a side, which spells a nice, and that's a nice word. So we'll call it SSA. That was an SSA triangle. So we were able to use the law of sines with an SSA triangle. Now, in this original problem here, the information we were given was, remember it was a highlighted part, we were given two angles and a side. So law of sine works great for AAS, right? Now, you don't have to memorize this, but just in general, a side note, law of sine does not work so well for side, 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 right? For the reason being that if you drew a triangle and you say new angle, this is 3, and this is 8, and this is 10, right? You don't have any partners. You don't know this angle, you don't know this. So this one doesn't have a partner, this doesn't have a partner. You have to have at least one known partner to use the law of sines. And if you have a side, side, side triangle, the law of sines doesn't work. Right? So law of sine doesn't work if you have side, side, side. For the same reason, law of sines doesn't work if you have angle, 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 because again, you won't have any partners. You have to at least know one partner, angle, side to make it work. It's also going to turn out that if you have side, angle, side, that also is not going to work because here's a triangle. Let's say, this side is 8, this side is 10, and this angle is 36. Find a partner. Well, you can't find this partner because you don't know that. And here, this partner, you don't know that. And here, you don't know that. So side angle side is not going to work either. So if you have any of these cases, law of sines is not going to work. And to do that, you're going to need the other law, something called the law of cosines, which we'll learn about tomorrow. So law of cosines will get you out of these cases. But for almost every other case, ASS or SSA, ASA, any other situation, the law of sines will work just fine. So the law of sines works most of the time. Now, there's one other thing I have to warn you about. If you have the case of AAS, the law of sines does work, but it's a special situation called an ambiguous case. And that's a whole nother lesson for tomorrow. That's actually a special situation. Law of sines works, but there's some catches to it, and you have to watch a whole nother video for the ambiguous case because there's some catches. So just be aware of that. We're going to learn that tomorrow. It's still law of sines, but it gets a little more complicated. All right. So law of sines will work in every case except these three. In this case, there's a special law of sines, and sometimes remember you have to use the sum of the angles of triangles to also help you get along to solve the triangle. So kind of hope that gets you out of everything. Good luck. It seems like a lot. There's other videos online that will also help you have more examples of how this works. So if you still feel a little lost, use those examples or see me in my office hours. All right. Thanks a lot.